Consider this triangle over here. The angles in any triangle add up to 180 degrees. So if you know 2 angles in the triangle, you actually know 3 angles in the triangle. You got to do a little bit of thinking, but you know it. If that's 100 and that's 20, because they've got to add up to 180 for any triangle, and you've already got 120, then the final angle must be 60. In any triangle, if you know 2 angles, you actually know 3. But what about in a right-angled triangle? Given that it's right-angled, of course, you always know there's a 90-degree angle in there. So, apart from the 90-degree angle, in any right-angled triangle, if you know one of the angles, then you know all 3. If you're told it's right-angled and you know one of the angles that's not the right angle, then you know all 3. In fact, these add up to 180. 90 plus 20 is 110, so 70 is left to add up to 180. But you can, if you like, ignore that and just say these two have to add up to 90. So the missing angle here is 70. But the key point is that right-angled triangles make it a bit easier in that if you know one angle, not the right angle, then you know all 3. Rather than as a standard thing for all triangles, if you know 2 angles, then you know all 3. A quick word about similar triangles. Similar triangles, just as with all similar shapes, it means they're the same shape. Same shape. Same shape. They can be the same size and be similar, but that's very special and we call that congruent. But just generally, if they're the same shape, so one could be little, one could be big, same shape means similar. And here's rule number 1 for similar triangles. If 3 angles of one triangle match 3 angles of another triangle, then we're similar. So they've got to have 3 angles in each one being the same. And we know for right-angled triangles, if we're told it's right angle, then if you know one angle, not the right angle, then you know all 3. So given 2 right-angled triangles with one angle the same, then they're similar, as long as it's not just the right angle. But I'll show you what I mean here. I've got a bunch of right-angled triangles here, spun round, different orientations. This one here, you might not be able to see it, but this one has a 20-degree angle down in that corner. Remember, they're all right-angled. You're told they're right-angled triangles. So this one's got 20 degrees. This one's got 20 degrees. That means they're similar triangles. That's got 20. That's got 20. If you know that's 20, then you know you've got 20, 90, and 70. You know all 3 if you know one angle in a right-angled triangle. That's not the right angle. So, similar, similar, similar. They're all similar triangles because all 3 angles are the same in all of them. If you wanted to write down that mathematically, you might write down that ABC is similar to DEF, which is similar to GHI, which is similar to PQR. All those triangles there are similar triangles. Now, instead of drawing a bunch of individual similar triangles, I could put all those triangles on the one diagram more easily if I wanted to. I could put them all in the same orientation. So I could draw one dirty grey triangle that's right-angled, like that, with a 20-degree angle in the corner. Of course, it doesn't have to be 20 degrees. I've just picked that for today. And I can actually make a bunch of similar triangles in this same triangle here just by saying, well, there could be triangle ABC, I'll call it. Triangle ABC. That little triangle there, it's got a 20, a 90, and a 70 in it. If you know one angle, you know all 3 in a right-angled triangle, as long as it's not the right angle. I can draw another one. Maybe I'll put a line here. So now this triangle all the way out here, which is just nested in the big triangle, it's going to be similar to triangle ABC. So if I call it ADE, triangle ABC, the little one, and triangle ADE have got to be similar triangles because they're right angled and they both got a 20 degree in them because all these triangles have a common angle. There's a big triangle here, a whole big triangle. I'll just call it AHI. So triangle AHI has a 20 degree, it's right angled. So I know it must be similar to this little triangle and the middle sized one and the big one. So if I feel like instead of drawing a whole bunch of individual ones and having the same angle in them, as long as they're right angled and then declaring that they're they're similar triangles, I can draw a set of nested similar right angled triangles quite easily just by picking the one same angle for all of them. That's going to be important in a later video when we do some measurement and generate our own trigonometric tables.